Good evening, welcome to Sakla Vidya YouTube channel. So, in the last session we have completed up to this conditional, that is simplification. So, now today we are going to discuss remaining concepts. So, now let us discuss 16th one. So, that is biconditional. Or it may be called as double implication. Okay, clear? Okay, let us discuss. So, now biconditional or double implication. So, this is also compound statement. So, we can state like this: if two or more simple statements are combined so by the connective that is if and only if so then the resulting compound statement is called biconditional or double implication. Okay. So, this is the actually biconditional or double implication, right. So, for example, here see, let P and Q be two statements, that they are two simple statements biconditional of P and Q is denoted by P if Q. P implies Q and Q implies P, that is P, this is R, we can say that P if Q. So, how do we define P if Q? So, that means in order to find out the truth table, so again the P if Q can be written like this now. So, that means P if Q is stated as, that is equal to P implies Q and Q implies P. So, from this we can write the truth table. So, truth table is very important. In this truth table you remember this note. So, here for example, if P and Q have the same truth value, then P if Q also same is always true. If both P and Q are same truth value, then only P if Q is true. So that means, for example, if P is true, Q is true, P if Q is true. For example, if P is false, Q is false, P if Q is true. The remaining all cases it will be false itself only. So that means, using this concept, now the truth table can be prepared here. So let us prepare the truth table now. So that means, simply we can write, if P and Q have the same truth value, then P if Q is true. In other cases it is false. So just remember this one. With the help of this, we can prepare the truth table for the biconditional. So truth table. Okay. So now right, this is P, this is Q, P if Q and Q if P. This is P, is Q, P if Q and Q if P. So now let us consider 4 cases. Here, what are the 4 cases? Let us consider. For example, true, true, both are true, both are false. If both are true, both are false, just like you remember like this, plus into plus into plus, plus means true, plus means true, you will be getting plus. False means consider minus, minus into minus, you will be getting plus. So that means, only in these 2 cases it will be true, true, true only. Remaining all cases it will be false. For example, it is true, it is false, simply you can write this is false, this is false. For example, it is false, it is true, this will be false, false. So this is the truth table for, so P if Q, P biconditional of P and Q. I hope it is very clear to you. And moreover, for example, if you observe these 2, the truth values of P if Q and Q if P, both compound statements, if you observe, they have the same truth values. That's why we can state that here we can remember 2 important points. P if Q is nothing but P implies Q and Q implies P, is very important point. And also here P if Q is equal to Q implies P, both are equivalent statements. I hope it is very clear to you, right. So now let us move to yet another concept, that is very, very important concept. So that needs to be discussed here. So once again, right. So next concept is very, very important concept, that is called tautology. What do you mean by tautology? Tautology. So you can chart. What do you mean by tautology? Just think. Do you have any idea? So, do you have any idea what is meant by the tautology? This is very, very important. Right, what is meant by the tautology? So, Mahesh Sardhana, yes, welcome, good evening, good evening. So, what is Mahesh? What is meant by the tautology? Do you have any idea? What is meant by tautology? Right. See, tautology means it's a always true statement. It is always true. So, yes, what do you mean by that one now? Actually, let us see once again. If all the truth values in the last column of a compound statement are true, that means are T true, then it is called a tautology. Then it is called a tautology. So, let us consider one example here. So, one example, let us consider one example here. So, example. So, let us consider P or negation P. So, this is the actually compound statement P or negation P. So, that means actually this is a interjunction of P and negation of P, Daniel of P. So, let us check its truth values now. So, now let us check. So, write down here truth values. The last column must be always true. See, now you can write this is P, this is negation P, this is P or negation P. So, let us write P, negation P, this is P or negation P, So, now you can write so truth values. See, now you can check the truth values. For example, this is true, this will be false. So, P or negation P, this is true only, true or false is true, sorry, this is true, this will be true only, true or false, this will be true, sorry, this is true or false only. For example, this is false, this will be true, again true, that is all. Only two cases you will be getting. Wait 1 minute, I will write. So, 1 minute, right. See, this is true, this will be false, negation of P. True or false is true. Next, for example, this is false, negation of P is true. So, that means false or true will be true. So, true only. Just check the last column. So, last column of this table is always true. See, if all the truth values in the last column of a compound statement are T, true itself only, then it is called tautology. This is very, very important. So, the best example is, so sure, good evening. Yes, definitely, but actually you need to share to your friends also, actually continue the classes. So, now that means example for tautology is best example. There are many examples. Then a best example is P or negation P. You remember this one. This is the example, one of the examples for tautology, right. So let us move to yet another concept, that is contradiction, So contradiction, what do you mean with the contradiction? See, contradiction means if all the truth values in the last column of a compound statement, or F stands for false, then it is called a contradiction. Previously, in the previous case, we have discussed tautology. Now it is a contradiction, right. So let us discuss about example for the contradiction. So example, so let us consider P and negation P. The previous case is P or negation P. Now it is P and negation P. So now let us write it's a table now, right. Try to write the table. So now P, negation P, P and negation P, right. This is P, negation P, P and negation P. Suppose this is see, for example, this is true, obviously false. See, true and false, if both are true only you will be getting true in the case of actually conjunction. So true and false means you get false only. So next again false and true means you will be getting false only. True and false is false. For example, if P is false, negation of P is true. False and true is false. So if you observe the last column of this table, always they are false, F only. So this is the example for contradiction. So let me just repeat once again, if all the truth values in the last column of a compound statement are F, then it is called a contradiction. The best example for, one of the examples for contradiction is P and negation P. For tautology means you remember very simple, P or negation P, example for tautology. So P and negation P is example for contradiction. I hope it's very clear to you. So next let us discuss, let's have a discussion on quantifiers. Do you have any idea about quantifiers? So quantifiers, these are also very, very important. Quantifiers, okay, quantifiers. So these are very, very important. So quantifiers are nothing but the phrases. So there are the two types of phrases are there, two types of quantifiers. So let's have a discussion on the quantifiers here. So you might have come across, yes, very good, universal and existential, absolutely correct, Mahesh, right. So generally we come across in mathematics, the language of mathematics, the quantifiers we have, the phrases, 1 minute. So let me write the phrases the phrases for all, or one more sentence, for every, next for no, these are the phrases. For no, there exists at least one. So you remember, all of you, the phrases what? For all, for every, for no, there exists at least one. These phrases are called quantifiers. So are called quantifiers. Right. So next here, see, note, write down, very important note. In that first point, write down the quantifier for all, for every is called the universal quantifier. Yes, absolutely correct. Universal quantifier. And next, it is denoted by the symbol. Symbol is very important. It is denoted by the symbol. It is denoted by the symbol. Right. So this symbol, for all or for every, we can say that for all or for every. So this is the symbol for universal quantifier. So all of you just remember. So this symbol means just like we write down like this. This is called for every or for all. It's a universal quantifier. So next note, let us write the second point. The quantifier sum there exists at least one. There exists at least one is called the existential quantifier. Clear? So it is denoted by the symbol. Okay. So this is called for some or there exists at least one. So you remember this symbol. So this symbol is for universal quantifier. Okay, this symbol is for existential quantifier. existential quantifier. Please all of you note down in your notes, because you need to prepare your own notes. Very simple question may be asked in your examination also sometimes. So, which of the following is the symbol for universal quantifier? Which of the symbol for existential quantifier? How many types of quantifiers are there? So, that you need to write in the examination also sometimes. I hope it is very clear to you. Okay. So, now let us have a discussion on the proofs, right. So, next let us have a discussion on, so next concept we have different types of the proofs. First is direct proof, direct proof. So, direct proof. So, generally in mathematics we have the, as far as pure geometry is concerned, we have the direct proof and also indirect proof, and also we have the counter example proof and contradiction method also. So, these are the proofs. So, let us have discussion one by one. So, what is meant by the direct proof here? So, in a direct proof, in a direct proof, in a direct proof, we start from the hypothesis and write steps using some already proved propositions, right. Axioms means self-evident truths called axioms, and establish the truth of the conclusion. So, this is the process of the direct proof. So, how do you arrive from here? You remember one thing, hypothesis to conclusion. So, that is called direct proof. So, generally we start from hypothesis and actually we come to the conclusion using appropriate already proven propositions or axioms. Clear? So, that means actually already proved propositions sometimes or even axioms also, we can establish the truth of that statement, truth of the conclusion. So, this is called direct proof. So, for example, let us consider one example here. So, one example, let us consider. So, let us consider. See, what is the statement? If x is odd, then x square is odd. So, now here if x is odd means this is given, then x square is odd. So, that means for example, if x is odd, we can say P statement, x square is odd means P implies Q. So, P is called hypothesis, Q is called conclusion. So, we need to write. So, here we need to actually consider this hypothesis and we need to come to the conclusion. So, let us prove it now, that is called direct proof. Now, here first of all, so let us give the proof now. So, solution here, first what is given, actually write down, this is x is odd, given, this is given data, we can write given. So, what is the general form of a odd number? What is the general form of a odd number? So, let us write x is equal to 2k plus 1. Here k belongs to positive integer. So, what is the reason? That reason you need to form it. General form of an odd number. So, this is the reason. So, we can write x is equal to 2k plus 1, squaring on both sides, because we need to show that x square is odd, so we need to square it. So, if you square, what do you get now here? X whole square is equal to 2k plus 1 whole square, right. Then what do we get now? Once again, see, x square is equal to, you get, so here 2k plus 1 whole square, So, if you observe right hand side, the right hand side is in the form of a plus b whole square formula. So, a plus b whole square stands for a square plus 2ab plus b square, am I correct? So, using this property, this 2k plus 1 whole square can be written as 2k whole square is 4k square plus 2 into 2k 4k into 1 4k, again 1 square is 1. From 4k square and 4k, otherwise you can take 4 common, you have 4k, you can take 2 common also. So, better you can take 2 common also, no problem. 2 common, what do you have? 2k square plus 2k plus 1. So, now here see, let us consider, let 2k square plus 2k is equal to something integer, because k is a integer, 2k square also integer, 2k also integer, integer plus integer is equal to integer, that is the actually closure property. So, now you can write 2l plus 1 form. So, what do you say? This 2l plus 1 is also a, since 2l plus 1 is also a odd number, an odd number. So, therefore, we can state that we concluded x square is odd, hence it is proved. So, this method is known as direct proof. So, you might have understood direct proof, right. So, next indirect proof, let us move to the indirect proof now, right. So, in the examination you are asked one question. So, how do you prove if x is odd and then x square is odd? What sort of method do you apply? So, simply you need to say that with the help of direct proof, if x is odd then x square is equal to odd, we can prove, right. So, next let us move to indirect proof, right. Let us move to indirect proof, right, indirect proof. See, in indirect proof, we assume, that means we assume the conclusion the conclusion q to be false, q to be false. First let us suppose that q is false, because we need to prove like this: P implies Q, P is hypothesis, Q is the conclusion. So, in this indirect proof we assume that the conclusion Q to be false, and we reach a contradiction after some steps, So, then we can claim that, so our assumption or supposition, that Q is false, is false. That means whatever our assumption is, we are going to prove that it is false. So, then right, Q is false, that will be established. Then we conclude that Q is true. So, that means our conclusion Q. So, that means negation of negation Q, that means indirectly. So, Q is false, negation of negation Q is always true. So, that means Q is true, that we are going to prove. Right. So, now let us prove one thing now here. One example, let us consider one example. If x square is even, then x is even. So, my dear aspirants, here see, x square is even is P, for example, this is then means implies x is even is Q, P implies Q. Now, we need to show that, let us assume conclusion x is even, let us consider Q is false, negation of this Q. What is the negation of Q? X is even means x is odd. So, first we need to start with like this proof. So, now the solution will be like this. Let us suppose x is not even, x is not even means this is negation of the statement, using negation of conclusion. So, we assumed that x is not even. X is not even means obviously what? That implies x is odd. X is odd means we can write x is equal to 2k plus 1. K belongs to positive integer, since this is general form of the odd number, right, general form of odd number. So, squaring on both sides, again you get x square is equal to 4k square plus 4k plus 1. Again take 2 common, you have 2k square plus 2k plus 1. Say this is L, 2L plus 1. This is nothing but odd. So, x is odd means you are getting x square is odd, but here x square is even. What you are getting? So, but actually what we are getting? we are getting even. Even is actually, this is a contradiction, it leads to the contradiction. So that means, so therefore our assumption is wrong. Our assumption is wrong. Is wrong. That means our assumption is wrong. Since it is a contradiction, it leads to a contradiction. So hence, so negation of this statement you need to write. Negation of x is not even means x is odd. Hence x is odd. So this kind of proof is called indirect proof. So you might have understood this one, indirect proof. So next, once again, one more proof we shall discuss, that is 22nd one, is called disproof by counter example. By counter example. By counter example. Counter example. So we need to disprove that given statement by considering a best counter example. So that means actually to prove that a proposition is false, a proposition is false, a proposition is false, a single example against the proposition is enough. That single example is called counter example. So let us consider one example here. All primes are odd. All primes are odd. Is this statement is true for all cases? All primes are odd. So all primes are odd means this can be disproved by simple example. One example is enough. So what is that example? Here you can write like this. So 2 is a prime number. 2 is a prime number. 2 is a prime number, but not odd. But not odd. So we cannot say that all primes are odd, because 2 is a even prime number. Even prime number. There are even primes, even number also there in the primes. Even primes are there. Only one even prime, that is the 2. 2 is a prime number, but not odd. So that's why all primes are odd is not a correct statement. Always not true. Clear? So it is disproved by counter example. This is called counter example. So 2 is a prime number is a counter example. Is a counter example. Right? So I hope it's very clear to you. Right. So now let us move to next concept. So next concept here, 23rd concept. So very important. These are actually De Morgan laws. Very important. Please note down, this is very important. De Morgan laws. De Morgan laws. De Morgan laws. So you may be asked one question on De Morgan laws also. De Morgan laws. First De Morgan law, very important. Negation of P and Q. This is P and Q is equal to negation P or negation Q. So this symbol reverses. Please remember, my dear students. So check the symbol. This symbol reverses like this. So one more example. Second one. Negation of P or Q. Negation of P or Q is equal to negation P and negation Q. That means they are the equivalent statements. This is very important. Please note down in your notebook. So, this is negation of P implies Q. This is very important. Please remember once again, I will write very important point. This is, you are asked to find out negation of the implication, negation of conditional. How to find out negation of the conditional is using this one. So, negation of conditional is P and negation Q. P and negation Q. This is the equivalent statement. P, for example, if you want to find out negation of P implies Q, simply you find out that is nothing but conjunction between P and negation of Q, then denial of Q also, negation of Q also. So, fourth point, this is very important point, double implication. So, negation of P if Q. So, this is equal to negation P if Q, or you can write P if negation Q. These are the De Morgan laws, very important, please note down. So, next tomorrow we shall continue for the objective type questions. Thank you, bye bye. Right.